What is crazing and why does it strengthen some plastics? Imagine a plastic part that seems to crack but actually holds together better than expected. That's what crazing can do in certain plastics. It's a fascinating process that affects how polymers behave under stress. When you stretch or pull on some plastics, tiny networks of small voids form inside. These voids are called microvoids, and they connect through very thin strands of polymer called fibrils. These fibrils are only 5 to 30 nanometers wide, which is incredibly tiny. Unlike a crack that causes the material to break apart immediately, crazes keep some load-bearing capacity because these fibrils act like tiny bridges. They hold the material together, even as the microvoids grow. Crazing usually starts at weak points in the plastic, like scratches or impurities. When you apply tensile stress, these weak spots cause microvoids to form and grow perpendicular to the direction of the pull. The crazes can stretch out several centimeters long but stay very thin, often less than a millimeter. If the crazing doesn't lead to failure, it can cause the plastic to look cloudy or whitish because of the way light scatters through the microvoids. From a failure point of view, crazing is important because it often happens just before the plastic breaks in a brittle way. It's common in glassy amorphous plastics and some semi-crystalline types. Thermosetting plastics are less prone to crazing because their molecular structure is cross-linked, which limits how much they can stretch and from these networks. Now, here's the interesting part about how crazing can actually make some plastics stronger. The fibrils inside the craze act like tiny reinforcement bars. They help the material carry some load even as the microvoids develop. This process absorbs energy and slows down crack growth, which makes the plastic tougher. In some blends, like those with polyhydroxyalkanoates mixed with more flexible phases, the fibrillar network within crazes gives the material extra strength. These tiny fibers aligned with the pulling direction help the plastic deform more before it finally fails. So, in simple terms, crazing is a microstructural change where tiny voids and fibrils form inside the plastic under stress. While it looks like damage, this network can actually help the plastic resist sudden failure by holding it together longer. Understanding crazing helps us see how polymers fail and how we might improve their toughness for uses in everything from packaging to medical devices and structural parts.